All right, so let me pull this up a little bit here. We're going to look at optimization problems. So this is all about how can we apply a derivative, right? That's what this whole chapter 4 is about, how we're going to use derivatives and apply them. And optimization is a good way to do that. Now, let me caution you. We're only going to do 2 types of problems, and our problems are going to be pretty wimpy. So here's what I want you to do. Yes, could on a lot of these problems you just trial and error and figure it out? Yes, but remember what we've talked about on multiple occasions. Calc 1 is like a developmental math. We are developing your skills in calculus. So what happens when you start with developing skills? You get wimpy little problems. So that's what's going to happen with this rancher's dilemma. And the next one we're going to do, these are wimpy little problems. Because they're wimpy, we're learning a technique. We're setting the stage so that as you progress, then you can build on this technique and get better. So yes, however, I realize you can solve these problems differently. We are going to use calculus, and you have to use calculus because we're starting the process of figuring out these skills so that later when you actually have a problem that's not so wimpy, you can actually do it. All right, that's our goal here. So with our rancher's dilemma, a rancher has 400 feet of fence for constructing a rectangular corral. One side of the corral has been formed by a barn and requires no fence. All right, 3 exterior fences and 2 interior fences partition the corral into 3 rectangular regions. We're going to draw this figure. What are the dimensions of the corral and maximize the enclosed area? What is the area of that corral? Here's the deal. There are some key words here that we want to look at. When it comes to optimization, words like maximize, that's your key. All right? I want to maximize. What am I maximizing? The area. So anytime you see that word maximize or minimize is valid. You can minimize something, right? And what have we talked about so far? If I want to take a maximum or a minimum, what is that? How do you get that? Setting that derivative equal to 0, right? So guess what we're going to do here? Get a derivative. So whenever I'm looking at this, I'm going to take the derivative, and what am I taking the derivative of? The area, because I'm maximizing the area. All right, so in order for us to do any of that, we got to figure out what the dickens we're talking about. Well, let's go back to the problem. A rancher has 400 feet of fencing. Okay. One side of the corral is formed by a barn. So here I have a barn. Ta-da! Oh, and it's rectangular, so that's good to know. Okay. And requires no fence. Got it. 3 exterior fences and 2 interior fences partition the corral into 3 rectangular regions. So 3 outside fences and 2 inside fences. That's what it's talking about. So over here I have the barn. We'll just call that a barn. And then I have the fences that go around it, and it is rectangular. So 3 around the outside and then 2 on the inside. How much do I have total again? 400 feet. Okay, that's what I have to work with. So I want to say, how can I maximize the area given 400 feet of fencing? And then what is it? When you build a fence, where is that? Is that on the inside? No. Where does a fence go? Around the outside. So if I'm thinking geometry, what is around the outside? What's that called? The perimeter, right? The perimeter. When I have a rectangle, I know that this length, this length, this length, and this length are all the same. Because it's a rectangle. It told me that in the problem. And then I have this length over here, which we're going to call y. That's the fence that I have. So if I want to say what is a perimeter of this, I have 4 x's and 1 y to give me my 400 feet of fence. Do you see that? Okay. However, my problem's asked me to maximize a what? An area. So if I want to look at this area, for my area, that's a rectangle. So if I have area is equal to x times y, because it's length times width, that's my area. Check this out. I'm not about to go in here and try to do some kind of implicit differentiation. I just want to find the derivative here of area. I don't have a value for area. I do have some information right here. So we're going to use it, and that's the point. If I manipulate this and say y is equal to 400 minus 4x, then that is the exact same thing, and I can take this and plug it in so you have a single variable you're working with. Okay, so for these optimization problems, you are going to be working with two equations. One of your equations is going to be with the information you're given. 400 feet of fence goes around the outside, that's a perimeter. Then I'm going to be working with a formula that I want to maximize or minimize. Either one, the same thing, the same process. If I want to maximize or minimize the amount that I'm looking at, that's the formula we work with here. But we want it in the same variable, so we're going to substitute that x times a 400 minus 4x. When you have just a single variable that you're going to distribute, or when you're going to take this derivative, just distribute, right? That's going to make our life easier. 400x minus 4x squared. Now, I want to maximize the area. So here is what we have for area. If you maximize, you want to figure out what can I do here. So with my actual area, I want to find the end points. What is the biggest area I can have and the smallest area I can have of my actual function? And then we'll say, whenever I'm looking at this value, is it going to work out with the materials I have? So if I want to figure out my endpoints are where I set this equal to 0. All right. So I can factor this. Factor out that 4x because that's what's in common. I have a 100 here minus an x. So x equals 0 and x is equal to 100, right? So that tells me the longest I can have for my fence, the shortest I can have for my fence is 0. So if my fence is 0, right, 0 for the x, that tells me how far these are. If each one of these are 0, what would that be? I would have 400 yards of this fence out here. Now, in order to build a pen, I could potentially just put fence all along the barn and have 400 feet of it. Is that much of a fence? No. But when you're doing this math, that is not realistic. The smallest thing possible is not realistic, right? So can it be? Yeah, this is the smallest I could have. That doesn't make sense. We're not going to do that. But mathematically, that's the smallest possible. Here's the other one. What if this was 100? 100, 100, 100, 100. Would I have any left over to connect them over here? No. Again, I could have 4 pieces of fence that are right up next to each other, right? And with nothing, no room in between. Again, not realistic. Not the best choice in reality. But mathematically, that's the highest I can have for this x value coming out. Okay, now we know our endpoints. Let's figure out our maximum. And in order to do that, I need to take a derivative. So when I take the derivative of this, I get 400 minus an 8x. Now, anytime you try to find a maximum, you have to set your derivative equal to 0. So we're going to do that. I'm going to add 8x to the other side just because I don't like the negative. So adding 8x is equal to 400. Divide both sides by 8. I'm going to scoot this up a little bit here. And x is now equal to 50, right? Because 8 goes into 45 times, yeah. And my label here is feet, so we're going to look at 50 feet. Now let's check this out. Is 50 feet part of my interval? Check. That works out. Nice. Okay. So if 50 feet is part of my interval, this is asking me, what are the dimensions? Well, I know x is 50. That's just these pieces. of my fence. I've got to figure out how much I put over there. Yeah, so you're going to take this 50 feet here, plug it in to figure out what your y is. So y is equal to 400 minus 4 times 50. So 400 minus 200. So I've got 200 feet that I'm looking at. All right, so my dimensions of the corral, when you start with words, you end with words. Therefore, the dimensions of the corral are 50 feet by 200 feet. Good. Is that the only question we had to answer? Nope. One more. What is the area of said corral? Okay, let me change colors just because it's getting crazy up in here. So my area is x times y. We now have an x and we have a y. So my area is going to be 50 times 200. And yes, I expect you to be able to do this without a calculator, for crying out loud. 5 times 2 is 10, and then tack on 3 zeros. This is area. So when you have area, you have a square unit. So the area is 10,000 feet squared. And that is our final answer. All right. When you have optimization, two equations. So you figure out your first equation with the information given so you can plug it into your maximum or minimum equation. Okay, good.